Hello viewers. So this is my first video and today I'm going to discuss the solution of Codeforces round 1049 and we'll be solving first three problems. This is my first video and in this YouTube channel what I've thought of is that I will upload contents of DSA and Codeforces solutions. Later on, I will also try to upload more videos related to tech, but DSA content and this Codeforces contest discussion, it will be constant unless and until like Codeforces is banned or DSA is not required in any company in the future. So yeah, uh, also about the screen sharing, there's some issue and because this is my first video, I'm not very much experienced. I will try to be very much professional, but there might be some issue. Okay, so I'm sorry in advance for that. Let's go to problem A, shift sort. Okay, so I think that you cannot see the problem. Wait a bit. Now is the problem visible? I think it should be. So you are given a binary string s of length n and you are allowed to perform the following operation any number of times. Choose three indices I, j, k, where I is less than j less than k, and right shift or left shift the values on si, sj, sk cyclically. Okay. So right shift or left shift. Okay. So we can choose any three random indices here and we can rotate it either clockwise or anti-clockwise. That's what the question is demanding. For the binary string, this okay, we if we choose I01, J2, K3 and perform a right shift cyclically, the string becomes 0 1 1 1 1 0. Okay, how it happens like that? So three consecutive indexes were chosen. Okay, so 1 1 0, and we did a right shift. So 0 came to the first position, 1 came to the second one came to the third. So yeah, okay. If we choose, okay, so these are the examples, and I won't take more examples because this is very simple. Now, what is the problem saying? We have to determine the minimum number of operations to sort the given binary string. Okay. Mm. And then we are given test cases. So four test cases, and in each test case, we will have a single integer which will represent the number of actually length of string, and then we have to find the minimum number of operations required to sort the given binary string. Okay, let's go. So yeah, again with a screen problem, let me go to my meeting. Mm, yeah, so I hope the whiteboard is visible. So I will be, yeah, now covering the solution here. So let's say that Let's take the best example, and I think that it's the third test case, 110100. 11, 11. Wait a bit, sorry. Uh, Is it this? Okay. Yeah, now it's fine. So 110100. 0100. Now we have to sort this string. So whenever I see this question, the first thing that will come to my mind is how will the string look if it is already sorted? So it will be 0 0 0 1 1 1. Okay. And how is the string right now? So instead of this 0, it's 1 here. For this 0, it's 1. So this is at its correct place. This is at its correct place. This and this are at wrong place. Okay. So can I say that the first three indices must contain 0? Now, what I'm going to do is I will cut this string into two halves. This is the first half and this is the second half. Okay, wait a bit. Hmm. And see, if we are given three indices, we can do one right shift and it will become like this. This k will become at this place. This I will go to j, the j will go to k. And if we do one left shift, then it will look like jki. Okay, this is left shift. This is right shift. So I know one thing for sure. In one operation, I can bring 1 0 here, and I will tell you how. Let's say that you see, first of all, let's count how many ones are in the first half. There are two ones. So we have two ones in the first half. In first half. But we require how many zeros? Three zeros. So due to this two ones, the string is not sorted. So what I will do, I will bring one. Okay. So will you agree with me that if there are two ones in the left half, there must be two zeros in the right half? It's like very obvious. Why? Because after sorting, we are getting three zeros here, and out of these three, one is already here. Okay, so to our left, then we are for sure that this two ones are replacing some two zeros. Okay, and which two zeros? I will say this two zeros. So can I bring 1 0 to any random one in the left in the first half in one operation? Let's say I will take this. I will take this one. Anyone like see. If you want to bring 1 0 to the first half, the strings, the three indices that you are going to choose must have at least 1 0. Because if there are no zeros, then why the hell are you doing the operation? So I will take one. I will take any random index from this second half. Let's say another one. Then I will take one 0. I will do a right shift. This one will go here, this one will go here, and this 0 will come here. So this will be changed to 0. Okay. And if I let's say take this one and some random index, let's say 1 and 0, then again you can bring this 0 to this place. Okay. Now you might be getting confused. See, if you take a 1 from the first half, then you can choose either 0 0 from the second half, or 0 1 from the second half, or 1 0 from the second half, not 1 1. Okay, these you can choose. Any of these you can choose. If you choose any of these, then for sure in one operation you can bring this 0 to this one. And how? Let's say this was the string. You do either left shift or right shift. 0 will come here. Let's say it was this 101, this thing. 101. Then you would do a left shift. 0 1 1. It would become 0 0 would go here, 1 would go there, and 1 will come here. So a left shift was required here. And what if it was 110? Then you would do a right shift. So 0 1 1. Okay. So did you get what I'm trying to say? What I'm trying to say is that you choose a 1 from the first half, then any random index, any random. Trust me, it doesn't matter. But the thing is that the third index must be 0 if second index was not 0. Okay. So this is the case. And this way I'll be able to bring all zeros to the first half. So what is the solution for this? Of course, I will count number of ones in the first half, and this is my solution for this problem. Count how many ones are present in the first half. And how will you know how many ones are present in first half? You sort the string. After sorting it, okay, don't sort the string. You just count how many zeros are there in the string. Let's say there are 7 zeros. So for sure, the first 7 index must be 0. I'm sure of this one thing. So you will just iterate from 0 to 7. Okay. 0 to 6, because it's 0 based indexing. And you will check how many ones are there in this first 7 indexes. That will be your answer. Okay. So do I need to code it? Wait. I'll try to code. So this is my template. First we'll input n, take a string, and then yeah, we have to count 0, that is equal to 0, and here count 0 equals to si equals 0. So 0 plus 1, else count 0. Okay. So I think you're getting what I'm saying. Now in the second iteration, I will go till count 0 and do count one plus plus. That's what I'm going to do. And I will create one more integer. So this will be my solution. I is equal to 0. I first counted how many zeros are there in the string. Then I will iterate from 0 to count of 0 and check how many ones are there in the string. So that's it. And if we check, hopefully it should work. Okay. So wait. The program is not running because now it should work. 2232. Okay, so what's the matter? In the first test case, we have two zeros here. And how many ones are okay? So yeah, what the hell was this? What the hell was this? I think now it should work. 0, 1, 2. Yeah, this code will work. So yeah, I think you got the logic, what I was trying to explain. Let's move on to the second question. Another divisibility problem. Think, wait a bit. So let me go to my boards again. Yeah, so now we'll solve problem B. I don't know why it becomes black again and again. Uh, Same thing. So we are going to discuss problem B. And uh, okay, so I won't switch off my screen again and again. So you just can go to the website and see the problem, or let me give you the problem link. So, wait. So the it's their problem. Yeah. So this is the link. I think you can just see from the website also. This is problem B of Codeforces around 1049. So yeah, okay. Let's just delete it. I don't even know how to use it properly. Okay, it's gone. So what the problem B says, we have Alice and Bob are playing a game in which Alice has given a Bob positive integer x less than 10 to the power 8. Okay. To win the game, Bob has to find another positive integer y less than 10. Okay. So we have x is equal x which is less than 1e8, y which is less than 1e8. If I'm not wrong. Okay. It's 1e9. To win, Bob has to find another positive integer y. Okay. So Alice had this x, and you have to find this y such that x hash y is divisible by x plus y. And what is x hash y? It's basically the concatenation of x and y. Let's say x is equal to 23, y is equal to 34. So they are basically saying that 23, 34. This must be divisible by 2, 3 plus 3, 4. That's what the question is saying. Nothing less, nothing more. So how would you go about this? How would you go? To be honest, this problem can be like very difficult if you go into the wrong direction, and it can be easy if you think correctly. Okay, so like you might go very wrong about it. So you are given an integer x. So let's try to observe one thing. If you concatenate a string y, or say an integer y, so what how would the number x be changing? Let's say that y was some one digit number. So can I say that 10x plus y, this will be the final number? Can I not say this? Of course I can say. If y was a two digit, and let's say x was a three digit, it doesn't matter how many digits x have. So x will be 10 to the power 2 into x plus y. How? Let me show you. Let's say x is 321, y is 12. So concatenation of 321 and 12 will be 32112. But mathematically, it will go like this because y has two digits. It's 321 into 100 plus 12. And what's that? 321 100 plus 12. That is 32112. Okay. So we are sure for one thing, that the new number that is formed is 10 to the power some t into x plus y by x plus y. Okay. This is my mathematical observations that I could uh, do for this problem. And there's a very simple thing in competitive programming or any problem solving. If you can derive an equation, not derive, I would say, if you can define an equation to a statement, I think most of the problem is solved there. And how? Let me explain. Suppose y is 2 times of x. Okay. And you will say that why only you took 2 times of x? Because, see, I know one thing, that this is my mathematical equation, and I have to somehow divide 10 to the power t x plus y by x plus y. So, do you think that if I take some random 2y or ky, will it be helpful? No. So, we would have to think of some y which is related to x. Now, why only 2x? I'm thinking because see, I know properties of a divisibility rule of 3. I know. I also know divisibility rule of 2. Okay. So I will show you how this is related. Divisibility rules are related. So 10 to the power t x plus first, okay, I will consider y is equal to x. Okay. So t to the power t plus x by x plus x, that is 2x. So it will become 10 to the power t x plus, okay, let me write here 10 to the power t x plus x by 2x. So x get cancelled out. So it's 10 to the power t plus 1 by 2. Is it ever going to divide by 2? Is it? 110% no. It will only divide if t is 0. And can t be ever 0? Tell me this thing. It can never be 0. Because if y was one digit, then you multiplied the x with 10 to the power 1. So t is at least 1 because y cannot be of 0 digits. Okay? Y cannot be of 0 digits. That's one thing. So my observation, or I would say assumption, that y should be equal to x is wrong. Now I will go y is equal to 2x. And why I'm going y is equal to x, then 2x? A very simple thing, that I don't want to overcomplicate it. Why like I would like to choose some simple numbers. So 10 to the power tx plus 2x by x plus 2x. If I take y is equal to 2x, then it will become 10 to the power tx plus 2x by 3x. Now this cancelled. That's x gets cancelled, and our final equation is 10 to the power t plus 2 by 3. Now, will it ever be divisible by 3? And my answer or claim is 100%. And why I'm saying it? Did you remember in fourth class, we used to study that if you want to check the divisibility rule of 3, you just add the numbers like 3, 4, 5, 6. So you will add 3 plus 4 plus 5 plus 6 and check if it's divisible by 3 or not. If it's divisible by 3, then the whole number is divisible by 3, else not. Okay. I think you remember this rule. So what is 10 to the power t plus 2? I don't know what's it, but I'm damn sure that if I sum the digits of these this 10 to this equation 10 to the power t plus 2, then I will have 1 which will be coming from 10 to the power t, and I will have 2 which will be coming from 2. So what's 1 plus 2? That's 3, which is divisible by 3. So I'm damn sure of this fact that if I take y is equal to 2x, then I will be sure that it's divisible by 3. So concatenation of x and y will always be divisible by x plus y when y is equal to 2x. So this is the final solution, which is one liner, and I'm not going to tell you how to code it. So yeah, please do code by yourself. Yeah, so let's move to the problem C. Um, See what's the problem saying. So again, I will say that you go to the problem link by yourself. It's Codeforces round 1049, problem C. So the problem states that you have a function for an array of length n, and function is your function a is equal to cost plus A1 minus A2 plus A3 minus A4, and so on. Okay, where cost is zero initially. Now consider the scenario where Alice and Bob are given an array of length n, then play a game taking at most 10 to the power 100 turns, alternatively with Alice going first. Okay, so they will be playing some game, and Alice will take the turn, and there are like 10 to the power 100 turns. So Alice going first. I think this is not very important, but it's important if you are going to observe. I think it's important. It's the key element of this question for me. But many people just, ignore this, and actually, it doesn't hurt if you ignore it. It won't matter. But for me, why it's important, because I will try to prove you that Bob is never going to succeed just because of this thing. There were like infinite terms, then the scenario would be completely different. So, what kind of operations they can do? So, the first type of operation is end the game for both Alice and Bob. Okay, end the game, end game. And the second operation is choose two indices L and R such that L is less equal to R, and swap these two. Okay. And after swapping, of course, the function fa is going to change. Okay. And this will add R minus L to the cost. If, say, cost was initially 0, so now your cost will become 0 plus R minus L. This will be the change that will occur to your function in addition to A1 minus A3 or A2 plus A3 minus A4 and so on. Why? Because indices are swapped. So yeah, this thing will also be swapped. Okay. So my first question is, how many operations is required? This is my first question, and this was my first question during the contest too, because the game cannot go up till 10 to the power 100. Like, Codeforces won't want you to do this much operation. Okay. So I thought of one thing, that if you are given an array AIAN, okay, and you swap two indexes, then you will add I minus 3 to your cost. Okay, let's call it J. Okay. So you will add I minus J to your cost, and of course, your answer will also be changed if uh, this is the odd position. So this is positive, and this might also be positive. It's if it's odd position. Okay, so that's a different story for now. Okay, I just want to explain you how many operations are required. Okay, we will cover to this approach later on. So let's say that Elias chose two indices, that is giving him the, okay, that is giving her the maximum answer. Okay, let's say that he chose integer such that he got maximum answer in this one operation. Not I'm not saying that uh this will be maximum operation answer even if he does five more operations. I was saying that in this particular operation, initial answer was 0 plus a1 minus a2 plus a3 minus a4 and so on. Why I'm saying 0? Because initially the cost was 0. And he made this function j minus I plus a1 minus a2 plus a3 minus L, okay, such that for this one operation, this gives us the maximum answer. Okay, so Alice want to maximize this equation and Bob wants to minimize this equation. So tell me one thing, if how can Bob minimize it? Alice goes first and he did some mess here, and now Bob has to clean this mess. So how can Bob do this? Will he not swap those two indexes again that were chosen, AI and AJ, in order to make it to the original? Okay, let's say that okay, so wait, not these two indexes. Let me give an example. Now let's say in second operation, Bob chose two indices AK and AL such that in this operation, using after this operation, the cost of this is minimized. Like it cannot be lesser than this minimized value if he choose some any random indices other than AK and AL. So there is one thing in every operation, and that is cost is always added. Initially, the cost was j minus I. Now the cost becomes j minus I plus L minus K. Okay. And cost is always increasing. This is one thing for sure. Now, in third operation, Alice will come and he will nullify the operation that Bob did. He will swap AK and AL again. And now the answer will be same as the first operation, but there will be one difference, that cost will be now increased to j minus I plus L minus K plus L minus K. Now it's even increasing. Now if Bob comes in the fourth operation and he tries to minimize the equation again, in the fifth operation, Alice will nullify his operation and the cost will be even more. So I think we just found the key element of this problem, that Bob can never do any operation in the array, in the array. He will have to end the game in the second move. End the game, end the game in second move. Okay. Now the question boils down to finding what two indices Alice must choose to maximize the function. That's the problem now. Okay. You don't need to find anything. You just have to find two indices such that the equation, or I would say this function, is maximized. Okay. Now, we can think of it like two cases. Case one. Okay, before even this case one, just tell me one thing. What is the alternative sum of this function, of this array? It's a1 minus a2 plus a3 minus a4 and so on. So can I say that it's a1 plus a3 plus a5 plus a time a 2 times k plus 1, okay? Because this is odd, and a2 plus a4 plus a2 times m, okay? Wait, I'll say minus of this, yeah, minus of this, or I would say just remove this bracket. Minus a2 minus a4 minus a2 times m. So if you swap any indexes with the same parity, will it make any difference? I don't think so, because it will still be a1 plus a3 plus a5. Okay, uh, let's say this. So if you swap a3 and a7, so do you think that a1 plus a3 plus a5 plus 7 is different than a1 plus a7 plus a5 plus a3? It just got swapped. So no difference. Similarly, if you swap these two, uh, any two indices in this equation, you won't find any difference. So in case one, I would say that swap two indexes with the same parity. So if you are swapping two indices with same parity, then you won't make any difference in this sum. Okay, and how will you calculate the sum? So when you are inputting the array elements, we will also add this thing. Okay, so this will be calculated when we are inputting the array elements, and then we will add the cost to this array. Okay, to this initially calculated value. Now this won't change if the parities are same. So we need to maximize this cost. And we know cost is r minus l. So if we are taking two odds, then maximum cost will be last odd index minus 1. This is first odd index and this is last odd index. And if we are taking two even indices, then last even indexes minus first even index, that is 2. So we'll get maximum cost. Okay. Now, what if we are taking two indexes with different parity? So let's say that you have sum Sm is equal to a1 minus a2 plus a3 minus a4 plus a5 minus a6 and so on. And you swap some indices with different parity. One is odd and one is even. So we know one thing for sure, that at even places we have a negative sign and at odd places we have a positive sign. So if this odd goes to even, this positive will go to negative and this negative will go to positive. So let's say this even was some a aj and this odd was some ai. Okay, so it was plus AI and it went to minus AI. So how much difference did this make to your sum? Okay, this is my one question. It will create a difference of minus 2 AI. Why? Let's say that initially it was 6 plus 3. Okay, this is sum of 6 and 3. And now this positive 3 is changed to negative 3. So you do it like this. So 9 and this is 3. So how much difference did you make? 9 minus 2 times this 3. Okay. I hope that you are able to understand this because it's very simple. Okay. And if you change AJ from negative to positive, so it will create a difference of positive times of 2 times AJ. So can I say that your sum will be initial sum, that is sum only, I would say sum plus 2 times AJ minus 2 times AI plus J minus I. Okay, because we will add cost also. Now we want to maximize this. We want to maximize this thing because this sum is constant as per mathematics because we already calculated it. Okay, so how will okay, so this is not constant because I already calculated it. This is constant because this is constant. This is the sum of our initial array and it cannot be changed. Well, some initial value cannot be changed. That's why it's called initial. Okay. I was just putting more pressure on this thing because I realized that by mistake I used the wrong statement. So it should never happen. Okay. So this is variable a 2 times aj minus 2 times ai plus j minus I, and we want to maximize it. So how can we do it? Can I say that we want to maximize 2 times aj plus j minus 2 times ai minus I? Okay. Or I can make it like 2 times aj plus j minus 2 times ai plus I. Okay. I will put these two numbers in this equation, in this bracket. So to get the maximum value, I will say we want to maximize this and we want to minimize this. Now I think you got it. And you also should know that this is some even number and this is some odd number. Okay, this is some even index and this is some odd index. Okay, that's why this, because we initially considered this aj as even and it changed from negative to positive, which brings a difference of 2 times aj in the equation. So this will be some even index and this will be some odd index. Now can you do it? Now isn't it a very simple solution? So yeah, if you want me to code, okay, let me show you the code also.